Continuing as we continue to look, let's make sure we've got the right share. Yeah. So we're going to continue looking at our derivatives as we look at problem 6. In problem 6, we have a product. Let's call this 9x to the 1/3 my first term. And then I'm multiplying that times the e to the x. So we have to use our product rule, which says it's the first times the derivative of the second, then plus the second times the derivative of the first. That will look like this. The first times the derivative of the second plus the second times the derivative of the first. Taking the derivative of this first will require us to use the product or power rule. So 1/3 will be multiplied by the 9, and that equals 3. And then we'll have x, and we'll take 1/3, our exponent, and subtract 1, which will give us a negative 2/3. This answer, there's so many ways you can simplify it. I'd probably just write the 3 in front. And if you were trying to solve this setting it equal to 0, you'd have to do more. But we don't have to do that here. Lots of different ways you could simplify it, but we'll leave it like this. Let's look at problem number 9. Now, on problem number 9, you could use the quotient rule, but it's going to be a lot easier to just convert this first. So instead of writing this as 1 over x squared plus x plus 4 to the third, it'll be easier if we rewrite this without taking the derivative, and we just call it x squared plus x plus 4 to the negative third. Now we can just use the chain rule. Remember, the chain rule says that if you have a composite function, an outside function, let's call that t of x, and an inside function, let's call that n of x. The derivative of something like this is going to be the derivative of my outside function, so the derivative of that, leaving the inside function the same, but then multiplying that by the derivative of the inside function. As we define that in the problem we see here, the x squared plus x plus 4 is the inside function, and the outside function is using the power rule, taking it to the negative 3 power. So as we take our derivative, we'll do the derivative of the yellow part, which is going to be negative 3 times the inside and then to the negative 4. So this is the derivative of the outside because we brought our negative 3 out front, and you subtracted 1 from the exponent to make it negative 4. The inside function stays the same at this stage. But now we take the derivative of my inside function. So the derivative of that would be the 2x and then plus 1, and the derivative of 4 is 0. So that's how we work with our chain rule here. Cleaning this up, we might want to write, let's see. So this negative 3 is in the numerator, and this 2x plus 1 is in the numerator. But this x squared plus x plus 4 really should be moved to the denominator because it's a negative 4. So we're going to write this answer as a negative 3 times 2x plus 1 over x squared plus x plus 4. And then once we move this to the denominator, it becomes the positive 4 exponent. Let's go on to problem number 8. In problem number 8, once again, we have the chain rule, but we want to rewrite the equation to make it convenient to use. So we're going to rewrite this as y is 3 minus x, and we're going to call it to the 1/2 power. And once again, we have the chain rule with the outside function being something, the power rule being taken to the 1/2 power, and the inside function being that 3 minus x. Using our chain rule, we'll have 1/2 times that 3 minus x. And then for the power rule, we take 1/2 and subtract 1 for the exponent. So that's how we'll get a negative 1/2. Then we multiply that times the derivative of our inside function, which would just be a -1, because the derivative of a negative x would be -1. Cleaning this up, we'd probably write it as 1, no, let's see, what goes in the numerator? Just that -1 is in the numerator. So we're going to call this a -1 over 2 times 3 minus x to the 1/2. Once we move this 3 minus x to the 1/2 to the denominator, its exponent becomes positive. Let's look at number 9. Number 9, once again, we have the chain rule. So the outside part of our chain rule is the e function to a power, and the inside part is that power. Using our chain rule then, we're going to get derivative of e to whatever is just e to whatever. So that's the derivative of e to a functional exponent. Now we have to take the derivative of the exponent, which is 2. So I'd rewrite this as 2e to the 2x as our derivative. On number 10, once again, it looks like we have our chain rule. So the outside function is my natural log function, and the inside function is the x squared plus 9. Taking the derivative of a natural log function is 1 over the argument. The derivative of the inside function is the derivative of the x squared plus 9, which is 2x, giving us our final answer of 2x over x squared plus 9. Thanks for watching. In our next video, we will continue on looking at derivatives.